In this section, we're going to introduce something called file expansion, or what some people refer to as globbing. If you're doing any research on Linux-related topics, you'll see it referred to in multiple different ways. Sometimes it's referred to as file expansion or file name expansion, and sometimes it's referred to as globbing. We're also going to introduce some special characters related to the bash shell that have different meaning depending on how you use them. And we'll show you some of these special characters have a specific meaning with some of the basic or more common commands that you're going to use on Linux. And what these file name expansion characters are going to do for you is allow you to essentially run a single command on multiple different files at the same time. It doesn't only just work with files. You can use it to do multiple other things, but let's go ahead and take a look at some of those examples to see what I'm talking about. So file name expansion characters. There's 4 basic types that we're going to talk about first. The first one is the question mark. Now the question mark's meaning can basically match any single one character. For instance, say I wanted to look at these files here that start with A and end in a number. I could do ls a question mark. Now that kind of serves as a single character wildcard that can match any single one character. So when I do that, it's going to return A1, A2, A3, A4, and A5. Similarly, if I did ls b question mark, it's going to return all the files that start with B and end in another letter. But if I said ls b question mark, it won't return anything because there are no files that begin with the letter B and have 2 characters after them. So the thing to remember with the question mark is that it can be any character, but it can only match 1 character. It also cannot match 0 characters. So there has to be at least 1 character, but it can be any type of character. It can be a special character, an uppercase, lowercase, a numeric value, anything. The next thing we're going to look at are square brackets. And square brackets can match any single character specified within the brackets, which also includes ranges. So for instance, with square brackets, I can do open ls, well, here I'll do, let's say A, comma B. So that says match A and the letter B, and then 1, 2, and 3. So this should match any file that begins with the letter A or the letter B and also ends in the numbers 1, 2, or 3. So that's how you can use square brackets. You can also do a range. For instance, ls a tag z would match all characters between A and Z. And then I could just put a question mark here. So we see that that returns all files that begin with A all the way to the letter Z. In this case, we only have files that begin with A, B, and C that only have 2 characters. And there's only 2 characters because this square bracket really only matches 1 single character. Now it can match any letter from A to Z, but only 1. And then the question mark matches 1 character, but it doesn't really care what that is. It can be a number, a letter, or anything. The next is the actual true wild card. It's the asterisk. And the asterisk, similar to a question mark, except for the fact that when we do a question mark, it only matches 1. And when we do 1 character, an asterisk can actually match 0 or more characters. So you can see that that returns files A2, all the 2 character files, and then it also returns a list of other files that just begin with the letter A that have far more characters in them. If I created a file that was just called a single character, it should also match that. And we see that it does. It's the first one on the line here. So an asterisk can match any character 0 or more. And that's a really useful file name expansion character that you'll probably use more often than anything else, or any of the other characters. The next one is curly brackets. And the curly brackets match any of the comma-separated values inside of them. And we can also use it for range. And I'll show you what I'm talking about. So for instance, I can say ls a, comma, let's say C, a question mark. And so that kind of works functionally similar to just saying, using the square bracket. It's going to return the same characters. But with the square bracket, we can do a range like this to match A, B, or C. With the curly brackets, what we can do is say A dot dot Z, and that will match everything within the range A to Z. Obviously didn't find these letters of the alphabet, but we found A, B, and C. We can also use it for number ranges. So A, 0 dot dot 9. So we see that actually returns A1, A2, A3, A4, A5, and it doesn't find a match for these directories. One of my favorite things to use that for is something like this, and I'll create like a little test directory here. So mkdir tester, cd into tester. There's nothing in here right now. And watch this. Say I wanted to create 1,000 files. That was my task for the day. Well, just typing, touch, there's file 1, touch file 2, touch file 3. To do that 1,000 times, that's going to take quite a while. With file name expansion, what we can do, and I'll go ahead and remove these, show you that there's nothing in here. I can say touch file 1 dot dot 1,000. Now we have 1,000 files created instantly because it does file name expansion and creates a file with the name file 1, and it goes through the entire range from 1 to 1,000. So that can be really useful if you're trying to create a bunch of files or something like that. Now a couple other examples I'll show you here. lsth star. This is going to find all files that begin with the word the. Oh, let's go back to my previous directory. Okay, so ls the star finds all files that start with the word the, but it doesn't really care what comes after it. For instance, if I created a file just called the and ran the same command, it would also be returned. Because remember, an asterisk matches 0 or more characters. If I said echo star the, what that's going to do is it's going to echo the name of all the files in this directory that begin with anything and have the word the at the end. Now there's technically only 2 files in here that actually have the word the at the end of the file name. So that's why those 2 files are returned. If I use the word count command on star the star, what it does is it counts the number of words, characters, and bytes, or number of lines, characters, and bytes in all of the files that have the anywhere in the file name. And it does that because there's an asterisk wildcard at the beginning and the end of the word the. So it'll match the literal word the with nothing before or after it, as well as any other file that has the word the at the beginning, the end, or anywhere in between. Next, we'll do echo question mark, question mark. And with that, we'll do, remember, question mark is a wildcard that can match a single character, but it has to be one character. So that's going to return any file that has 2 characters in the name. Next, what we'll do is, first we'll do an ls for all files that start with chap. So these are like different chapters. And I'm going to remove rm every file that starts with chap and then has the number 0 through 9 after it. Now if we do that ls again, we should see less files, and we'll notice that all the files that had 0 through 9 and nothing else after that were deleted. So like chapter 1, 2, 3, 4, 5, 6, 7, 8, and 9 are now gone. All the files that say chap A through G, as well as chapter 10 through 20, are still present. Next, I'll do a WC, and here we'll use curly brackets, and we'll say H, comma, M, LO. So what this should do is it should do a word count on a file called hello and a file called mellow. And it finds both of them and does the command on both files simultaneously. Next, we can do a similar command, WZ BR, comma CL. So here we're using 2 characters that end in ing. So a file that starts with BR or starts with CL and ends in ing. So bring and clean. Next, what we'll do is we'll run the rm command, and here I'm going to use the square brackets, but I'm going to use a not symbol. And that not in a lot of different programming languages and scripting languages